Hello YouTube, this is Chester from STEM API guys. Welcome to another tutorial. In this tutorial, we're going to continue where we left off in the last tutorial. As you recall, in the last tutorial, we were creating surfaces and windows, and we added the GLFW images library so we can create windows and add a lot easier ways to do things as we go deeper into this series of tutorials. In this tutorial, we're going to dig a little bit deeper. We're going to be digging into the swap chains and how to create a swap chain. Swap chains are very important in the Vulkan API. And as you can see, this is from the Vulkan Programming Guide, the official guide to learning Vulkan. It says in order to actually present anything to the surface that we created in the last tutorial, it is necessary to create a special image that can be used to store the data in the window. Swapchain objects are used to ask the native Windows system to create one or more images that can be used to present into a Vulkan surface. As you remember, in the last tutorial, we created the Vulkan surface and the Vulkan surface window. We're working in the Linux world. If you so if you comes from the Windows world, you would be using this guide. You would be using the Vulkan Create Windows 32 surface from Kronos. But being that we're Linux people, we're using the presentation either on the XLib based platforms or the XCB platform. In my case, it's an XCB. I'm using Ubuntu 64, 1804. So let's get started into the code. This is a really a much longer uh, uh, code, and that's exactly why we in the last tutorial I explained that we couldn't pack all of that code into the main function like we've been doing because the code starts getting a lot longer, a lot more complicated. And I'm not going to go over every piece of detail. I'm just going to try to um, point out the layers that are new in the code. For example, here the Vulkan Chrono Swap Chain extension names. This is new, it's a new vector, and I will point some of them out. You can you can see in I will keep a copy of this in my GitHub page, so if you want, you can uh, pay more, detailed attention to what is being done. So you can see there's some in basically very similar to the last tutorial, but this last struct here is new. This is struct for the swap chain support details, and it's the surface format and the present mode from Kronos. We continue here, creating the Vulkan swap chain instances, initializing the GLFW window, creating Vulkan, creating the surface, creating the logical device, but now we're also creating the create swap chain, which is new. And we continue here. This is mostly the same. Nothing has changed here from the last tutorial. But in this part here, it gets now, this is the create swap chain function, swap chain support details, the surface format, the present mode, and I will be printing something so you can see what that means, and you can understand a little bit better what an image count, what a surface format, and how that all ties together with what we've been doing. We continue here the get swap chain, the present mode, choose swap present mode, and that is basically the same from the last tutorial. And check validation, and that's almost very similar to the last one. So what are we doing here in this case? Let's explain here. Here I'm printing out what an image count in surface format. And in order to know what these things are, if you want to learn more about it, you can go here into the formats. These are all the formats created in the Vulkan API. This is which one is this one? Vulkan, this mine, and it's the format. I'm going to get a number, and we're gonna come back here and see what that number is, and see if it corresponds to what it should be. In here, this is from the last tutorial. This is the GLFW, the header file, and the Vulkan guide, and the Chronos quick reference guide that I showed you in the last tutorial. So let's run it, and then I will show you what it does. Clear these, and to run it, this is the code right here. Is the create Swapchain C++, and make file is the same one that we've been using, but I've changed it to create Swapchain C++. Oops, I gotta change that also. Create Swapchain, and then let's close it, run it, and now the little make. It executes cleanly, and it creates a surface, and there it is. This is our window that we had from last time, but let's minimize it. But here are a few things that are very important, and we're going to um, talk about it. We found an enumerated physical device, which is true, just like we have done in other tutorials. Is I only have one graphics card, but it finds the device extensions count 53, and we were going to look at what these numbers all mean. Device present mode count equals 3. Device present mode, oh, actually did it twice for some reason. Sorry about that. The minimum image count is 3, and the GPU device surface format is 44. What does that 44 means? Let me explain to you what this means. If we go back into the format, and it's the Vulkan format from the C specification of the Vulkan API. And if you go down into this list here, you're going to find a number 44. And it corresponds to the Vulkan format UNorm VGR A8. The B, the G, the R is color. It's a color space. Instead of being RGB, it's just like in OpenCV. If you've seen some of my tutorials, they use the VGR format, which is 8, 8, 8, and then 8 for the alpha channel. So basically the blue, green, red, and the alpha channel. And if we want to make sure, if you don't believe me, we're going to close this one here for now. And let's go back to our friend, Vulkaninfo, and find some of these details in that about our system. In this case, count 15 extensions, instance extensions, that's from a few tutorials ago. But as you can see, after the layers, we get into the part that we're doing right now. These are the presentable surfaces. We're doing the presentation right now. And we created a surface and window and a swap chain. And there it is. VGR UNorm BGR A8, just like I show you. Present modes are count equals 3. The XCV surface, because we're in the Linux world, we're not using Windows 32. And there was something else that I want to show you here. There it is. Device extensions that count 53, and there, here they are. Okay, that's where these numbers are coming from. And now if I stop it, these are where these numbers are coming from. The 53 extension count, the present mode for 3, the image count is 3, a minimum image count. That has to do with double buffering or triple buffering. And the surface format, which is 44, which corresponds to the BGR Alpha 8, 8888 BGR A. And this the end of this tutorial. If you like this tutorial, please click the like button, subscribe to my channel, and we'll see you next time with another tutorial. Have a great day.